This is a video walkthrough of Problem 1 on Practice Exam 1 of Module 1 in the book Problem Solving Guide for Electromagnetism and Optics. There are plus 2 nanocoulomb charges at 1 centimeter 0, 2 centimeters 0, 0, 1 centimeter, and 0, 2 centimeters. What is the electric field at the origin? You have to give the magnitude and direction because the electric field is a vector. Of course, we have to start with a good diagram. Find these charges in a two-dimensional coordinate system. There is a charge here, 1, 0, charge here, 2, 0, 0, 1, and 0, 2, and they're all plus 2 nanocoulombs. We should label them. Same magnitude charge. What is the electric field at the origin? There's no charge at the origin. It's empty space. We want to know what the field is here. We can put a positive charge there. We can imagine it's going to accelerate in this direction. The charge at 1, 0 has a strong electric field to the left. This charge has a weaker electric field to the left, 1/4 as big because it's twice as far away. Here we have a strong electric field down produced by this charge at the origin, and this charge is farther away. Its field is also down. We have to sum these 4 field vectors to get the electric field at the origin. It's going to be something like that. First step is to get the magnitude of the field produced at the origin by each of the 4 charges. The charges that are 1 centimeter from the origin have a strong field. It's kq over r squared. Converting the units, that's 1 centimeter, 0.01 meters. 2 nanocoulombs is 2 times 10 to the minus 9th coulombs. We get a field strength of about 180,000 newtons for every coulomb. The charges that are 2 centimeters apart have an electric field strength of about 45,000 newtons per coulomb at the origin. The only difference here is the 2 centimeters in the denominator. So now we have the lengths of those electric field vectors. Now we have to add them up. In the x direction, these 2 vectors are easy to add because they're parallel. We just add their strengths. It's minus because it's to the left in the xy coordinate system. So the electric field in the x direction from these 2 charges, about 225,000 newtons per coulomb to the left. In the y direction, we have about 225,000 newtons per coulomb downward. So now we have 2 vectors at right angles. We have to add those up, and we can use the Pythagorean theorem for that. And we calculate the magnitude, about 318,000 newtons every coulomb, 45 degrees below the negative x-axis, and we should draw it in there. There's the electric field at the origin, there's the magnitude, and there is the direction. Problem 1, Practice Exam 1, Module 1, Problem Solving Guide for Electromagnetism and Optics.